Hello everyone, welcome to this session on artificial intelligence. In the last video, we talked about the basics of AI and talked about the journey which AI has taken in last 75 years, the key milestones, and who are the pioneers. And we gave a basic introduction on various domains which are involved in the AI. So now we will be exploring each domain one after one through a separate video series. So this is a video which is focused on machine learning. So, how machine learning came into existence, what it consists of, and how it has led to the overall AI revolution. So, moving ahead, this is the agenda we will cover. So, what is machine learning? Then we will discuss on the types of machine learning, that is supervised learning, unsupervised learning, reinforcement, and semi-supervised, and how these are different from each other, and when to use which. In which business case we have to use which one. That we will discuss in detail. Then we have classification and regression as the two techniques of machine learning, which are very, very important to understand. We will discuss on them. And again, we will understand when to use which. Then we will explore various algorithms which are there in machine learning area. And we will focus on data preprocessing, feature engineering, EDA, which is actually the AI lifecycle, and how models are processed. We will talk about some of the business cases which comes under machine learning, and then we will have a session on jargons and libraries. So, talking about machine learning is about learning from the patterns of data. So, when machine tries to learn, it basically processes data and tries to extract patterns from the data so that it can generate its own map and understand the data in its own peculiar way, such that whenever any new input comes, it is able to give the output based on the patterns which it has learned. So, this is the fundamental of machine learning. If I give an analogy from the real world, then the Mumbai Dabbawala story makes a good analogy. So, the Mumbai Dabbawala are very famous. Prince Charles had come and he had given award to them when he came to Mumbai, because without using any app, without using GPS, without any automation or AI, they are able to achieve the same level of accuracy of Six Sigma, which we always, all companies try to strive to achieve for. So, if we see the story of Dabbawala, how they learn and how they progress over with time, then we will be able to correlate it with our machine learning journey. So, how they learn? So, they learn every day when people leave home, where they work, and when the trains are least crowded. So, all these are events which becomes the learning data, and based on the data, they take decisions. Excuse me. Over time, they notice patterns like which road is free, which gets blocked, which customers need lunch early, and which stations are the busiest. And based on this data, they create their own map, their own patterns through which they are able to predict the next action. Whenever a new tiffin arrives, based on its past learning, they are able to quickly identify what path it should take. The entire success comes from spotting patterns, following them, and improving them. And even if there are some difficulties, like if the trains are late or roads are flooded, they adjust accordingly and try to deliver in an alternate way. This is exactly what machine learning does. It makes small improvements every day, learns from the mistakes and experiences, and keeps updating its experience knowledge base. So, the machine learning landscape, it encompasses various methodologies. There are various types of machine learning. So, first is supervised learning, where we have the label data available with us. So, the data has the label as to what the data is, and it is easy for the machine to learn because it knows what the data is, what label it has. So, based on the label, it creates its own map. Second type of learning is unsupervised learning, where we don't have labeled data. So the data is unlabeled. So here we have to discover the patterns in the data on our own and then classify them. Then we have reinforcement learning. It is about all trial and error and rewards. So we learn through trial and error, and if we are successful, we get reward, otherwise, we get penalty. And in this way, we keep on refining and reinforcing our thought process, reinforcing our experiences, and it keeps improving with time. And then we have semi supervised learning, which is a combination of label and unlabeled data, because there are so many cases where you might not have complete label data, but you might have few label data available. So these are the various types. Now we will go into detail of each one of them. What is supervised learning? Supervised learning is the most common, where algorithms learn from labeled training data. It is provided with input output pairs, allowing it to learn the relationship between features and their corresponding labels. So it is like a teacher who provides correct answers during training. So it has a label data available, it has clear objective, it knows, it learns to predict specific known outcomes, and error correction is there, right? So if we take the analogy of supervised learning, it is like the cricket coach. So the cricket coach will train the players in a way where he will give them different balls and he will label each ball, whether the ball is an outswinger or in swinger, and then based on the labeled balls he will teach the students how to tackle the ball. So after months of label practice sessions, each delivery explicitly identified and explained, the batsman develops the intuition. So this is supervised learning in action. The coach will represent label training data and the batsman in the ML model will learn from these examples. This is used in healthcare diagnostic, customer churn prediction, sentiment analysis, credit risk assessment. Over here, we in all these cases we have labeled data with us. So in healthcare, we have labeled images of cancer and non-cancer patients. So based on that, the machine learns and then it is able to predict the next outcome. In customer churn prediction, also we have details about which customer is going to leave and why the customer leaves, the exact details of those cases. Similarly, in credit risk and sentiment analysis. So this is what supervised learning is. Now we will come to unsupervised learning. See, in unsupervised learning, there is no labels on the data. So instead, the algorithm has to discover the hidden patterns, structures, and relationship within the data. This is valuable for exploratory data analysis where you don't know the patterns which exist. You have to cluster the data and arrive at the patterns. Okay. So no labels are required, pattern discovery is there, data exploration is there. So discovering hidden patterns. In various examples are clustering, where automatic clusters of data are formed. So if you take a real world analogy, so in a wedding, if you see a lot of people, you don't know their groups, but you are able to figure out that there are kids running at one end. So there is a group of kids, there are elderly people who are talking to each other, office colleagues are chatting in formals, and college friends are taking selfies. So after seeing the crowd, you are able to identify and cluster them as to which what all these clusters are. This is exactly what happens in unsupervised learning. Dimensionality reduction. So reduce large number of features into fewer meaningful ones. It is like zipping a large file. Then we have anomaly detection. So detecting something which is unusual, abnormal, or suspicious. So from a real world analogy, it is like identifying the fraud. So if someone from Mumbai usually spends 500 2000 daily, and then suddenly there is a spike and there is a transaction of 75,000, then it is flagged as anomaly. So these are the examples of unsupervised learning. So there are a lot of business cases where both this comes into picture. Unsupervised learning is there and supervised learning is there. One real world analogy is about the clustering at Dadar station. So we all know in Dadar station in Mumbai there is heavy rush. Okay, but the fascinating thing is that there is no label. Students come over here, or office goers come over here, or the other laborers you come over here. Okay, so it is a single platform. It is a single platform where the patterns emerge automatically. Office professionals form one line and they go from one side into the train. There are students who form one line and then they take some separate coach. There are people with luggage who form one particular group, and then there are street vendors who have their own group. So nobody guides them into this group. These clusters form naturally based on the behavior, appearance, destination patterns, and timing. This natural self learning mirrors the unsupervised learning, where algorithms discover hidden patterns without labeled examples. So, when no one tells the data what to do, unsupervised learning helps it find its own tribe. In practice, if you see market segmentation, anomaly detection, recommendation systems, okay. So, Netflix story, if you take an example. So, basically, Netflix gets lot of views on daily basis of some millions of subscribers without predefined categories. So basically, it does not know that this user will go for action movie or this will go for documentary movie. But with time, based on the data, the unsupervised algorithm is able to understand that okay, these users, this type of users, they are action lovers. They go for action lovers because based on the past data pattern, they have mostly seen action movies. Similarly, it discovers other patterns. So this algorithm identifies clusters of users with similar viewing behavior. One cluster might watch science fiction, other might prefer romantic comedies, and there will be third group who will look for documentaries. So these naturally emerging patterns enable personalized recommendations. So this is a classic example of unsupervised learning. Then what is reinforcement learning? Reinforcement learning is a learning where an agent learns by interacting with the environment. It takes actions and based on the actions it either receives a reward or penalty. And hence if it receives reward, then it gives more marks to that action gets repeated. If it receives penalty, the action gets disqualified. So it is like a child learning a bicycle, right? So when the child starts learning a bicycle, it tries to take one step at a time, and when it realizes that taking this step will lead to a crash or he will fall from the bicycle, next time he will not take that step, he will take another step. And when he gets the feedback that okay, now taking riding the bicycle in this way will help him not to fall, then that is where he will become perfect in that. So there are agents, there are environments, state, actions, rewards, and policy. This is how the reinforcement learning is completely stacked up. So we have self-driving cars, we have industrial robots, then AlphaGo system, recommendation systems. These are all reinforcement learning. So in self-driving cars, what happens is that the car taking an action which is correct increases the probability of that in the future. So it gets an feedback that this action was correct and you should give more weightage to it. Similarly, in the robots, when the robots do any right action, they get the right feedback. And if they do any wrong action, they get wrong feedback. So this is how reinforcement learning works. Here we have the Mumbai train analogy again to explain this in a very simple way. So If a new person is coming on a Mumbai local train, so first of all, he will start his exploration. He will board the front coach, which will be extremely crowded, and then he will get penalized. He will have a very bad experience. So then next time he will learn from his experience. He will label it that taking front coach is a bad choice. Then he will continue his exploration. He will try middle coach. Again, he will get penalty. Then he will discover, okay, second last coach is less crowded. So that particular choice will give him reward, and hence it will reinforce the positive experience. So in this way, he will keep on optimizing, and finally he will form a policy that okay, second last coach is the highest reward coach, so I will always take the second last coach. So this is exactly what reinforcement learning is. And then we come to semi-supervised learning. Semi-supervised learning is a learning where we have small amount of labeled data and there is large amount of unlabeled data. Okay, because we cannot get more labeled data in certain cases. So we start with a small labeled data set, then we learn on that labeled data set, then we add unlabeled data set, and based on our initial learnings from labels, we discover the unlabeled data and then integrate the knowledge. So it is a combination of supervised and unsupervised learning. So an analogy for this is just imagine there is a classroom of 50 students, but 5 students have all the answers key to the questions and 45 students don't have. So 5 students with answer key will start solving problems correctly and then they will begin explaining the same to their peers. The remaining 45 students attempt problems on their own using their understanding. Through peer collaboration, they will compare the approaches and identify patterns in problem solving strategies. And the teacher occasionally reviews and corrects the key students, ensuring correct knowledge is propagated. So, over a time, the entire class achieves strong performance, far better than the 5 labeled students alone. This is exactly how semi supervised learning works. There are a few labeled examples. So, if we take the analogy, then we will have e commerce, cybersecurity, right? In cybersecurity, the labeled data set for intrusion is very less as compared to the unlabeled data set, where we don't know what the data is. But the data of intrusion is very less as compared to the overall data. Similarly, in autonomous driving, road scene understanding, object and pedestrian detection. So all these comes under these industry applications. Now, so we have multiple algorithms in machine learning at our disposal, and we have to choose the right learning paradigm. So how to choose that? So the concept goes like this: whenever you have labeled data, go for supervised learning. Some examples are fraud detection, medical diagnosis, price prediction, and image classification. Whenever you have whenever you have undefined data, unlabeled data, you have to definitely go for unsupervised learning. So customer segmentation, anomaly detection is the best example. Then semi-supervised learning. So whenever you have some amount of data which is labeled and other data which is not labeled, then you have to go for semi-supervised learning. Like in medical imaging, so there will be so many images, but very few will be having cancer. So the cancer label data set is very less as compared to the overall data set. And then reinforcement learning is when decisions must be made sequentially with feedback consideration. So robotics, game playing, autonomous vehicle, trading systems, all of these come under reinforcement learning where learning is a key aspect. So choice depends on your data availability, the problem type, and the desired outcomes. So there is an exercise over here. So what approach should be taken? Predicting whether a customer will default on a loan. So because here we have labeled data, we will take the supervised learning approach. Similarly, we have so many examples. So I have just given the answer for them. We'll go through each one of them. Grouping customers into similar behavior. Because we don't have any labeled data, we will use unsupervised learning. Then we have choosing the fastest delivery route for a Swiggy driver. So initially we don't know what is the fastest route, but we keep giving feedback, and then the route keeps on improving. So it is reinforcement learning. And classifying medical x-rays with few labeled but many unlabeled images comes under semi-supervised learning. So in this way we can classify our business problem and identify which machine learning method we will be using before we go ahead with the actual implementation. Now we will come to the two most important techniques which are used in machine learning and otherwise in AI, and these are classification and regression. We will understand them in detail. So classification is a supervised learning task where goal is to predict discrete categories of classes. Okay, so you have to classify among one of the discrete category. So simple example is like whether the document is a PAN card, Aadhaar card, or a driving license which the customer is given, or a passport. So you have to choose one out of these four. There is a finite possibility, and you have to choose one out of those. That comes under classification. Wherever the problem is multi-class or binary, the classification models are used. So this is like the mango vendor analogy. Okay. So there is a APMC market is there in New Bombay. So mangoes come in the morning. They issue 1,000 fresh mangoes. Okay. And they have a similar challenge of sorting it quickly and accurately into various quality grades. So A grade is a premium quality, B grade is regular quality, C grade is discount quality, which are overripe. So how the pattern recognition happens? So the vendor checks the mangoes based on the color, aroma, firmness, size, and texture. And through the experience which he has built all over these years, he is able to classify them into one of these categories. So here we have a list of categories where we have to classify and based on the features. So this is how the classification algorithm works. Some examples are banking and financial services, retail and e-commerce, healthcare applications. So all of these they have labeled data and they have finite labels out of which you have to select one. So either it is binary, for example, the customer will pay loan or not pay loan, or it is multi-class. Like for example, I gave the PAN card, Aadhaar card. So the document can be anything out of these five, but it is finite. Then we come to the another end of the thing, that is regression. Regression is supervised learning technique we use to predict continuous numerical value rather than discrete categories. So wherever you don't have 4 to 5 or 10 categories out of which you have to classify into one, you have a category which may take any value, continuous value. There we use regression. So where we have continuous output, we have relationship modeling and forecasting power. So basically, based on the historical patterns, you forecast what the value of next value will be. A simple example is about the share market. So based on the history data, you will forecast the value of the particular stock. Now this value will not be from a discrete number of values. Okay, it can be anything. Today it is 330 rupees, it can go to 350, 370 or 1000 also. So there is no discrete set. It's a continuous changing variable. So wherever we have a continuous changing variable, we use regression algorithms. So analogy is compute time prediction. So every day the time to reach office from home will differ. It will depend on various conditions. Definitely distance is one thing. Second is the route which we take, the traffic conditions, the weather factors, and the time of the day. So every time it will have a different prediction. It will be a continuous numerical value. Sometime you may reach in 55 minutes, sometime you may reach in 60 minutes, sometime you may reach in 45 minutes. So since it is a continuous changing value, it is a case of regression. So one good example is the real estate price prediction. So the price of a house depends on so many factors and it's never constant. A simple change in the vicinity may trigger the cost of the price to rise like anything. So, for example, in New Bombay, if the airport is coming, new airport is coming, then all houses which are within the vicinity of new airport, their prices will rise immediately. And there is no discrete value. It can rise to any level. Hence, this is a regression problem. Same, we have energy consumption, battery degradation forecasting, stock price analysis. All these are regression. Sales forecasting, how much will be the sales? Call volume forecasting, how much tickets we will get in this month. So all these are regression problems because there is a continuous changing variable. Now we come to the algorithms. So first is the linear models where there is a linear relationship between the variables. So when you hire a taxi, more distance is more fare. So there is a linear change in the data based on the conditions. Second category is distance based models. Okay. So things which are close together are similar. So generally you will dress like your closest friend of circles. If there is some particular day, then you will always try to dress like your friend and your circle. So if your five closest friends are having sneakers, you are most probably going to wear sneakers. So this exactly is the concept. It finds the nearest neighbors to decide the output. So based on the nearest neighbors, it is able to predict the output. There is no linear relationship. Then we have tree based models where decisions are taken in a tree form. So random forest, decision tree, gradient boosting. Simple rule is if then else. So if you have fever, yes. Then do you have body pain? No. Then do you have cold? The step by step it goes ahead. Okay. So instead of trusting one doctor, we may ask multiple doctors, and if majority of them says that you have flu, then we have flu. Then there is a student which is improves after each test. So each test shows the mistakes. Next one focuses only on weaknesses, and next test fixes even more, boosting the algorithm like an improving student. So these are the various types of algorithms. Then we have probabilistic models where probability is important. So based on certain symptoms, what is the probability of having a flu? If you get such kind of business cases, then you have to go for probabilistic models. So CCTV evidence is there, fingerprint evidence is there, then there is more chance of coming to the final conclusion. Then there are margin based models, support vector machines, support vector regression, right? So two villages are on opposite side. You build the widest possible road in between. The more space, the safer. So it finds the safest boundary. Similarly, you have neural network models, which are totally deep learning based. So it learns like human brain. So a child sees many images of dogs and cats, and slowly it learns the features, shape, patterns, everything becomes clear, and then the child is able to identify which one is dog, which one is cat, because the brain is able to form the full picture as it has learned the edges, corners, shapes. This is exactly what CNN algorithms do. The third category is polynomial models, where there is not a linear relationship, there is a curved relationship. It is like a river flowing through hills. Where the water will go, you cannot predict because it all depends on the mountains, valleys, and rocks or the growth of a child, right? So it's a non-linear pattern. So wherever you have non-linear pattern, you can use polynomial models. Then we have cluster-based models where clustering is done. So this is most probably used in unsupervised learning, right? So you group the similar items first. So if you are getting so much traffic and you want to classify them as good traffic, bad traffic, first of all, you will start forming the clusters of traffic which have similar features because you don't have the label data with you. So With such a thing, you will be able to form multiple clusters and then identify each cluster, whether it is a anomaly or it is a normal traffic, right? So automatically, analogy is like shirt, pant, socks. Even without knowing their names, we are able to sort them based on the features which are there visible. Then when we come to deep learning, there are so many variants. So RNN is there, LSTM is there, transformers are there. All these we will learn in detail in deep learning session. But simple principle is that you remember previous word to understand the next one, and you give attention to the words. Okay. So this is the concept of deep learning. This is a chart of algorithm. So linear, what is the classification, what is the regression algorithm, and what is the simple analogy. So for linear, we in classification we use logistic regression, and in regression we use linear regression. It's a straight line logic. Polynomial is a curved pattern. Distance base is how the neighbors are. Tree base is like if then else questioning. So we have so many models which we can learn. Now we come to the techniques of the machine learning AI life cycle. So everything starts with a business case, and then the second thing which comes is the data gathering and then data pre-processing. So basically we clean the raw ingredients before cooking. In the similar way, we clean the data before giving it to the model. So cleaning data consists of various topics. So basically it is about handling the missing values. So if data has some missing values, we fill them with the average so that when it goes to the model is able to process something. If it's a blank value, the model output will go haywire. Then we handle outliers in data. So what are outliers? So in a company, the CEO salary will be 1 crore or 2 crore per year, and the average salary of a person will be 50,000 per month, right? So it comes to around 6 lakhs per year. So there is a huge difference between 6 lakhs and 1 crore. So 1 crore is an outlier. So if we feed this data into the model, the averaging will get impacted and the model output will get impacted. So we have to handle the outliers. Either we cap them, we remove them, or log transform them. Then we have encoding categorical features. So as you all know, the algorithms, they only understand the numbers. So if you have features which are non-numbers, you have to convert them into numbers. That is what encoding categorical feature means. Suppose if the city is Mumbai, Delhi, Pune, so you will convert it into a matrix 1000010. So instead of giving Mumbai, Delhi, Pune, you will give this particular vector. Then we have scaling. So if there are two parameters where the algorithm is working on, so one of them is age, other is salary. Now the age is a very small number and salary is a very big number. So these two numbers are way different, and we have to bring them on a single scale so that algorithm can understand it. So we use standard scaler to convert these numbers between 0 and 1. Then we have to remove the duplicates. Duplicate values will lead to more confusion. So wherever there are duplicates, we drop them. So basically, in the real world analogy, it's about before cooking, you wash the vegetable, peel them, cut them, remove the ones which are not good, remove the noise, dirty data, missing values, outliers. So this is how you clean the raw data, where we don't modify the meaning of data, but only the cleaning is done. So this is how the pre-processing works. Now we come to a very important concept of feature engineering. So what is feature engineering? So everything All business cases have features, and features identify the functionality of that particular business. So, for example, if we take the case of loan defaulting, then in loan defaulting, whether the customer will default the loan in his next EMI. So, there are so many features involved. The features are like, what is the salary of the customer, what is the EMI of the customer, what is the EMI to salary ratio, does the customer has more other loans, what is his CIBIL score, where has he defaulted before. So there are so many features which are interrelated, and finally making a sense out of all of these is what feature engineering is. So what you will do, based on your business problem, based on what you want to achieve, you will focus on the various features and engineer them. You will drop features which are not at all important for the model to do the prediction. So, say for example, there is a male or female gender. So, gender is not going to make any sense in loan defaulting. So, we will remove that feature. We will drop that feature. We will fix the weak features, and then we will create new powerful features, enhancing the existing features. Okay. So, create new features to give the model hidden insights not present in raw data. So, the example is debt to income ratio. So, debt to income ratio is not a feature which is readily available, but we will create a new feature of debt to income ratio by using two features and dividing them. So, this feature will be more beneficial in finding out if the customer is going to default or not. Then, dropping some features. So, when the feature is irrelevant, it leaks data and has too many missing values, then or is either constant or almost constant, then there is no meaning of that feature as far as the model processing is concerned. So we will drop them. For example, customer ID, invoice number, then there are columns with greater than 60% missing values. There is no meaning in using that. We can easily drop them. Or constant columns like countries, India for all the rows. Then there is a concept of reduction of features. So too many features will cause overfitting. So we remove correlation, select top key features, and then we reduce features. So if there are 5 features which contribute 95% importance, then we drop the remaining 30 features. Model becomes faster and avoids overfitting. So for example, we have area, carpet area, build up area, right? So instead of having all of these, we keep only one because all of them are equal. So keeping all of them will not make any sense. There are some examples of feature engineering. Some user features are there. Then we have some product features, interaction features. So purchase frequency and recency, average order value, preferred categories. These are the features which are derived, right? Then we have product features, price tier categorization, popularity score, review sentiment score, category embeddings, seasonal demands. So for various different cases, we will use different techniques to do feature engineering. And that will improve the overall model output. So why we are doing feature engineering? So that it helps in improving the overall efficiency, accuracy of the model. Similarly, we do EDA, exploratory data analysis, which is very, very important step in any life cycle of AI. So what it does, it is basically visualizing the data through various graphs, then having some summaries, domain reasoning, pattern identification, and problem discovery, so that you know what the model will learn from. So checking the data shape and structure. This includes number of rows, columns, data type, distribution of columns, unique values, right? So we understand how big the data is, what are the fields in the data, and what are the type of fields. Then we understand the missing values and their patterns. So there should not be any bias in the model which breaks it. So 40% income fields are missing. It indicates customer did not declare income. This has strong business meaning. People hiding financial details are often risky. So we go deep into data and understand the patterns of data basically. Then detecting anomalies and outliers. So there are so many graphs which we plot, and based on that we come to know what exactly are the anomalies and what are the outliers. So if suppose a transaction is 10 crore in a retail data set, clearly a fraud indicator. Then we identify correlation structure. So how the data is correlated to each other. So though amount is positively correlated to income, age and credit score is slightly correlated. Income and default is negatively correlated. So we understand the correlation. Then we visualize everything. We plot a lot of graphs, histograms, box plots, count plots, and all these libraries are available. You just need to invoke them. So it is like a, then we find some patterns, trends, and business insights. So based on our algorithms, based on our histograms and various other graphs, we come to know about the hidden insights and patterns in the overall business. So, for example, sales spike before Diwali and machine failure rises after 2000 hours, and fraud spikes at the end of month. These are some of the patterns which we, as a human, we discover out of the data using all these charts and other methods. So, EDA is like a full body checkup before surgery. So, you check if you whether you have BP, sugar, ECG, any abnormality in the heart, or any other issue before you actually go for the surgery. This is the exact analogy. So, what are the EDA for common project types? For customer EMI default, demographic analysis. So, analyzing where the customer stays and what whether he owns his house, financial behavior patterns, default rate analysis. So, for each business case, there will be different set of EDA which needs to be done. For dynamic airline pricing, we have historical pricing patterns, demand analysis, competitor pricing, customer segmentation, right? For image, we have class distribution, image quality assessment, pixel value distribution. So these are the five pillars of model selection: the nature of the problem, the data characteristics, interpretability. Interpretability means that whenever any decision is taken by AI, then how much important it is for you to know why the decision was taken in from a regulatory perspective, from a compliance perspective, from an explainability perspective. So if you are required to explain each and every move, then interpretability is very, very important, and accordingly you have to choose the algorithms or the models. Time constraint. So training duration, how much is training duration? Business context. So based on all these, we select the model. So this is something about how we match problem to model families. So structured prediction task is classification, regression, clustering, and time series. And unstructured data challenges are handled by computer vision like CNN, NLP algorithms, or high dimensional data like SVM and Neubase. Data size also drives the algorithm choice. So if we have small data sets, decision trees and logistic regression will be helpful. In medium data set, random forest and XGBoost will be helpful. And for large data set, we generally go for deep learning because it quickly helps in unlocking the patterns of data. So size will also determine which algorithm needs to be used. So basically, we come to the interpretability and performance trade-off. Whether interpretability is important for you or performance is important for you. So there are some cases where we have more weightage on the interpretability. Like if you are rejecting a loan, and if the government is going to ask you why you rejected the loan of the customer and what AI has done to come to this decision, then interpretability is important. So you have to use algorithms which help in interpretability. Where moderate interpretability is required, random forest gradient boosting can be used. And where interpretability is low requirement, but you need good efficiency, then you have to go for deep learning and transformers. This is the industry standard model evaluation workflow. So split data, you have to split into training and testing set. Then you have to train multiple candidates. So experiment with multiple algorithms and see what is the output. Then do hyperparameter tuning. So this is like tuning those parameters of the model to which you have access, and then do some experimentation and see how the model efficiency changes with all this tuning. Then validation of the evaluation. So metrics are there. We select the metrics and see how it actually scores. Overfitting check we have to do, means we have to analyze training versus validation score to ensure generalization. It should not happen that for the test training data it is giving good efficiency, but for testing data it is failing like anything, right? Business validation and model finalization. So now we will come across various jargons. We will discuss them. What is underfitting and overfitting? So what is overfitting? Overfitting happens when a model memorizes the training data too perfectly, including noise, mistakes, and random patterns, and it fails to perform well on new unseen data. Right? That is overfitting. So it gives very good efficiency in the training data, which it has seen and it has learned. But when you give it the testing data for prediction, the efficiency drops significantly. Cricket analogy, practicing only on home pitch. So if a batsman is doing very well on the Mumbai pitch, which is his home ground, but when he goes to Australia, he is not able to make runs. This is exactly what overfitting is. Underfitting is the model is too simple and fails to learn the underlying patterns. It fails even for the training data. So it's like a doctor thinking that all infections are viral infections. So he will not diagnose whether it is malaria, dengue, or typhoid. So it is like underfitting. Overfitting has very high accuracy on training data, but it drops suddenly on testing data. And underfitting has low accuracy on both. Now, the metrics which are used in classification and regression, we will go through them. So, what is the accuracy? Accuracy means how many total predictions the model got correct, right? So, for example, if you take 100 questions and you get 90 right, 90% is your accuracy. Then, why there are so many metrics? Because only one metric cannot be used, because depending on the cases, some metrics may be more important, other metrics may not have that much weightage. So, for example, when this accuracy becomes misleading, if data set is imbalanced, a model predicting no fraud always will get 90% accuracy, but it is useless because then we have to detect the fraud. So, even though the accuracy is high, that 1% fraud is what is important. So, then comes precision. Out of all the people I said are guilty, how many really are? So, it is the efficiency of the decision. When the model says yes, how often it is correct. The police arrest 10 people accusing them of theft, but only 6 actually did the crime. So precision is 60%. Then we have recall. Recall is out of all the guilty people, how many did I catch? So I am trying to see how many positive cases I was able to successfully identify. So there are 100 criminals, but I only able to catch 80. This is used when missing positives is dangerous. So, like missing cancer patients or missing fraud cases or missing anomaly detection or fault machine in manufacturing. Then there is a concept called as F1 score. So it is a balance between precision and recall. Single score balances both precision and recall. Think of a cricket all-rounder. A player must bat well and ball well. A balanced player has the best F1 score, used when data is imbalanced. Then we have confusion matrix, which is a scoreboard of predictions. It shows correct yes predictions, correct no, wrong yes, wrong no. So it is like a scoreboard showing everything, the runs, wickets, boundaries, right? And we have ROC curve. So it shows how good the model is across different thresholds. So how good it is across different cases. Think of a metal detector at the airport. If you make it very sensitive, it detects more bombs, but also flags harmless objects. So you have to maintain the ROC curve so that it shows performance at every sensitivity level. Regression metrics. In regression algorithms, we have metrics like mean absolute error. So average absolute mistake, average of how far predictions are from actual without direction. So expected delivery was 3 days, actual delivery took 5 days. So error is 2. Mean square of error punishes big mistakes more. It is same as MAE, but it's the squares of error. So if 1 mark is small error, 10 marks is error 100. Using models where big mistakes are dangerous. Root mean square error. Standardized penalty for big mistake. If your house price prediction is error is 1,50,000, RSME tells you this number directly. This is the root square of the MSE. Then we have R square and MAP. How much variance is expected? And MAP is mean absolute percentage error. Shows how far predictions are in percentage terms. So all these metrics are very, very important. Hyperparameters. Hyperparameters are those settings or controls or knob which we have in our control for the algorithms which we can tune. So they decide how fast the model learns, how complex the model becomes, and we choose them basically. So it's like setting of a washing machine. So you want to set the water level, you want to set the spin speed, temperature, and these settings decide how clean the clothes will come out, right? So there are so many hyperparameters which you can tune. Trying different combination of settings to find which setting give the best performance. So you have best accuracy, best precision recall, best AUC, lowest error, and there are hyperparameters are learning rate, depth, trees, neurons, epochs, batch sizes. So you tune these parameters in a model and see how the overall efficiency or the metrics improve. Why it is important? Because it increases the accuracy, increases recall, it reduces overfitting and underfitting, and improves the generalization. With one with a poor hyperparameter is a useless model, and with good hyperparameter becomes an outstanding model. So this is something in your control and you can change it. So what are the different parameters? Learning rate is one. Controls how big a learning step the model takes. So flame level by cooking basically. Whether the flame is too high or too low. Then number of trees. How many trees the model builds. So more judges is better decision. Then max depth. How deep the tree is allowed to grow. Right? We have epochs. How many times the model sees all training data. It is the number of revision cycles before an exam. Batch size. How many samples the model learns from at once? What is the batch size? Is it a small batch or a large batch? Then we have neurons, the size of neural network, number of people in a decision making committee. So more layers is more intelligent model. So there are so many business cases. Loan EMI default prediction. So if you see, the bank must predict whether a customer will default on EMI or not. So here classification is used because it is a classification problem, either default or not a default. some data used is customer income, credit score, age, loan amount, etc. etc. How the ML model works? The model learns patterns from thousands of customers who paid on time, who missed EMI, and using this pattern, it predicts the likelihood of default for new applicants. Similarly, we have fraud detection in credit cards. Identify whether a transaction is fraudulent. Again, classification problem because either transaction is legitimate or it is a fraud. Data used is transaction amount, time of transaction, location, merchant type, etc. etc. How it works? Model learns what normal behavior looks like and what suspicious behavior looks like, and then when new transaction comes, it is able to classify it. In medical diagnosis, cancer detection, right? Again, it's a classification problem. Either the data is showing as a benign or it is showing as a malignant. So the tumor size, texture, smoothness, cell shape, biopsy results, image data, everything is very important. The model learns from thousands of such past cancer diagnoses, and then, like a senior doctor, it is able to identify. Then same business cases for regression. So house price prediction we already discussed, predicting the price of a house when you want to sell it. It's a number, and data use is house area, number of rooms, location, age of property, amenities, nearby schools, metro stations, etc. Right? So larger area will definitely have higher price. So like a real estate agent estimating price, the ML uses millions of transactions to predict accurately. Sales forecasting. How much will be the sales? Again, it is a number. So it's a regression problem. Data uses past sales, seasonality, festival impact, weather data, etc. etc. How it works? Summer, more cold drinks will be taken. In festivals, more clothing will be taken. And end of month, more grocery orders. So these all patterns will be learned by the regression algorithm, and then it will do the right prediction. Insurance premium prediction. Again, it's a numerical value which may vary. So it is a regression problem. So age, income, health, these are the parameters, and model is able to find more accidents is high premium, older age is higher health premium, and healthy lifestyle is lower premium. Machine learning libraries. So there are so many libraries which you can explore. NumPy is there, Panda is there, Scikit-learn, Seaborn, Matplotlib. So NumPy is for numerical computations. Pandas is for data handling. Scikit-learn is for all the machine learning algorithms and the whole life cycle. You can use Scikit-learn. Seaborn and Matplotlib are for exploratory data analysis. TensorFlow is for basically used mostly in where text is involved, natural language processing. Then we have Keras. Keras simplifies deep learning. It is a deep learning library. PyTorch, again deep learning library. OpenCV is for computer vision. Stats model is for time series modeling. And then we have so many machine learning jargons which you can have a look at. Yeah. So in this way, we have covered the complete machine learning concepts. What all are the types of machine learning? What all are the various methods? How to choose the right algorithm? What are the algorithm metrics? We discuss multiple business cases and the whole life cycle as to how to go about with each step. So thank you for your time and welcome to the next lecture. It will be on the next AI topic. So till then, thank you to all of you and goodbye.